All right, welcome. Let's solve some systems of equations. We're going to start with some substitution ones. And so, okay, oh yes, I see it. Started out pretty easy. So with y equals -5 and 5x plus 4y equals -20, my strategy is I'm going to substitute on y. So I've got 5x plus 4 times y, which I now know is -5. That's going to add together to equal -20. Okay, so that's 5x plus -20 equals -20. Okay. Maybe you can see what x is going to be right here, but it's going to need to be x equals 0, right? If I add 20 to both sides, then I'll get 5x equals 0. And that tells me that x needs to equal 0. So my solution is x equals 0 and y equals -5. Okay, that was number 1. For number 2, okay, I'm going to again substitute on y. And when we have them both solved for y, what we can do is just set these two pieces equal to each other, right? You can say I'm going to substitute on this y with 4x minus 9. You can say I'm going to substitute on that y with x minus 3. It's going to end the same way, right? So we've got 4x minus 9 equals x minus 3. Okay, I'm going to collect all my x's to one side, so I think I'm going to subtract 1x from both sides. And then I'm going to add 9 to both sides, get all the numbers over here. And so if I take -3 and I add 9, that would be 9 minus 3, that'll be 6. And then I'll divide both sides by 3, and that will be x equals 3. Okay. This one isn't really set up exactly prime for substitution, but I could get it there pretty quickly. You know, if you looked at this and you're like, oh, I want to double equation 2 and add them together and do elimination, you can do that, right? It's no big deal. But I'm going to solve this one with substitution because that's what it said. And so I'm going to solve for y here. I'll probably move that over there, move that over there. But I'm going to solve for y in this equation, and then I'll substitute down there. Okay, so if I add y to both sides, I'll have 4x equals y plus 20. And then maybe I'll subtract the 20 from both sides, and I'll get 4x minus 20 equals y. Okay, and then I'm going to substitute on this y right here in the other equation, because if I substitute on y in this equation, I end up getting 0 equals 0. It's like, okay, well, you know, that's true, but that doesn't mean infinitely many solutions if we plug in back on the same equation we were working on. So if I go over here and I say, all right, -2x minus 2y, which I now know is 4x minus 20, that's also y. Wait, no. I don't know. -2x minus 2y, that's equal to 10. So that doesn't seem right. Okay, now I'm going to distribute. I'll have -2x minus 8x plus 40, because -2 times -20 would be positive 40. That'll be 10. Okay, when I subtract these, I'll have -2 minus 8. That's going to be -10x. Okay, I'll subtract 40 from both sides, and I'll have 10 minus 40 is -30. So it looks like x needs to equal 3. Okay. And I've got a formula for y. If you wanted to go back to one of these, it's probably safer, but you know, I trust the work I did over here. So I'm going to say y equals 4x minus 20. Okay, that's 12 minus 20, so it's going to be x equals 3 and y equals -8. I'm realizing over here I never did y for this one, right? I got x equals 3, y equals x minus 3. Okay, that's not too hard. I can say y equals 0. Pardon me. All right, now we're going to solve some using elimination. This will be more exciting, maybe. All right, so I look and I say, like, how am I going to eliminate? And my plan here for number 4 is to eliminate x. And so if my plan is to eliminate x, I need to double this equation. So I have positive 16x and negative 16x, and I can get rid of x's. So I'm going to double the first equation, so I have to double everything. Nope, that's going to be 16. That's just all around bad. All right, so if I double this, I'll have 16x minus 12y equals -40. And then this second equation the same. Then I'm going to add them together. And I'll say 16x plus -16x, well, that's 0. 7y minus 12y will be -5y. And if I take 30 and I subtract 40, that's -10. Okay? So if I divided both sides by -5, I'd get y equals 2. And I can go back to either of these equations, whichever one you think is going to be easiest to work with, and get your x. So 8x minus 6 times y, which I now know is 2, that's going to add up to negative 20. Okay, so 8x minus 12 equals negative 20. If I added 12 to both sides, negative 20 plus 12, that'll be negative 8. And then if I divide both sides by 8, I can get x equals negative 1. So x equals negative 1, y equals 2. That's my solution. Okay, this one, this is not looking like it's in good shape. I've got 10x and 11x. Those don't have a common factor. I have negative 10y and negative 4y, and those are both even, so I'd probably be able to, I don't know, probably scale this one up to 20 and that one up to 20 and do elimination. That's going to be my plan. So I'm going to even write that up. Okay, so if I'm going to eliminate y, I need to have the kind of the same number of y's in the opposite sign on each side. So I think what I'm going to do is I'm going to take this equation and I'm going for 20y on both. And so I'm going to scale this one up by 5 times. Okay, so I'm going to multiply the whole first equation by 5. And so that would be negative 55x minus 20y equals 36 times 5. Well, 30 times 5 is 150. 6 times 5 is another 30. That's going to be 180. And then, okay, this one I'm going to need to multiply everything by negative 2, so I get positive 20y. So if I multiply negative 10x by negative 2, I will get positive 20x. I'll get positive 20y. And then I got to multiply this by negative 2, and that will be negative 40. Okay. Now I'm ready to add these together to do elimination. And I'll say, all right, negative 55 plus 20, that'll be negative 35. And then no y's is going to add up to be 140. Okay, well, 35 times 2 is 70. So it stands to reason that 35 times 4 is 140, so I know that x is going to need to be negative 4. And then, personally, I'm going to go back to one of the original equations because the numbers are lower, and I'm going to find my value of y. So I'll have negative 4y minus 11x equals 36. And all right, so negative 4y plus 44 equals 36. Now if I take 36 and I subtract 44, that's going to be negative 8. So I'll have negative 4y equals negative 8. I could divide both sides of this equation by negative 4, and I would get y equals 2. Or I could think about what do I need to multiply negative 4 by to get negative 8, and again, positive 2. Okay, so there's my solution for that. Number 6, I have to just squeeze this in over here. Okay, I've got 2y here and 2y there. Okay, you've got 7x and negative x there. So if you wanted to scale this one up by a factor of 7, you could do that to eliminate x. I just don't think that's going to be the thing to do because, you know, if you multiply 21 by 7, we're going to have some really big numbers. Whereas we could just multiply one of these by negative 1 to get a negative 2y. And, you know, I think I might do that. Maybe I'll do this one because it's already got this negative here. So if I take equation 1 and I multiply it by negative 1, I'll have negative x minus 2y equals positive 19. And then if I copy in the next equation, I will be set up to eliminate y. Okay. And, all right, so now I'm going to go over here and add these two equations together. And negative 7x plus a negative x is going to be negative 8x. 19 and 21, that's going to be, well, that's going to be 40. Yeah. And so if I divided both sides by negative 8, I could say that x was going to be negative 5. And then if I needed to know what the value of y was, I could go back to one of these equations. Maybe this one. Negative x plus 2y equals 21. Right. So this is 5 plus 2y equals 21. I'm going to subtract 5 from both sides of this equation. And then I'm going to divide both sides by 2. I'll see, okay, y equals 8. Okay, so x equals -5, y equals 8. That's going to be my solution there. Okay. So that was some good substitution and elimination. And I gotta say at this point, if you need more practice, I've got more substitution and elimination practice. It's just like very dry. Here's the system, solve it. And you know, I would probably put links to those in the description of the video. So number 7, the sides of an equilateral triangle. Oh, this is the one where I typed it up wrong. I should have just snipped it. I was trying to get it to fit all on one side of one sheet. The perimeter of the square is 42 inches more than the perimeter of the, we're going to say, triangle. Okay, so I think the first thing here is we're going to want to draw 2 pictures. So the square is going to have side lengths x and x. The equilateral triangle is going to be y, y, y. Okay, you could call the side lengths of the square y and the other thing x, but then you'd get the same area because we're going for the area of the square, which is just going to be a number. Okay, so the side of the triangle is 4 inches shorter than the side of the square. So the side of the triangle is y, means equal, 4 inches shorter than, okay, I'm going to subtract 4 from the side of the square, which is x. Okay, then the perimeter of the square, that's 4x, is 42 inches more than something I'm going to add 42 to is going to be the perimeter of the triangle. Equals 3y plus 42. Okay, well, this system is really set up for substitution on y right there, okay, using x minus 4. So I'm just going to do that. Okay, so 4x equals 3 times x minus 4 plus 42. Okay, and that's going to be helpful because I need the area of the square, so really all I need is the side length of the square. Okay, so I'm solving for x. I don't really need y. Okay, so I've got 4x. I'm going to distribute this 3 over to the x, 3 to the -4, and plus 42. Okay, so 4x equals 3x plus 30. Then I'm going to subtract 3x's from both sides. 4x minus 3x is just going to be 1x is equal to 30. And if x equals 30, then my square is 30 by 30, and the area, well, that's going to be 900. And that's how we did that one. Okay. Here we've got another kind of geometry problem. The perimeter of a rectangle is 46 feet. If the width were doubled and the length were increased by 5 feet, perimeter would be 66. And we want to know what is the length of the original rectangle. Okay? So I'm going to just draw this. You know what? I'm just going to use W and L for width and length. Okay, so perimeter is 46. So 2 W's plus 2 L's. That's going to equal 46. If the width were doubled, okay, you know what, I'm going to just draw a second rectangle. And the length were increased by 5, then the perimeter would be 66. Okay, well, so 2W plus 2W is going to end up being 4W. L plus 5 is going to be 2L and 10. That's going to be 66. Okay, so I think I probably need to just simplify this a little bit. Maybe I'll subtract 10 from both sides to get it kind of set up for elimination. And I'll have, all right, 4W plus 2L equals 56. And then, okay, if I'm going to do elimination, I probably want to have like a -2L. So I'm going to take this whole equation and multiply it by -1. Then I'm going to add them together. 4W plus -2W, that's just going to be 2W. 2L minus 2L, that's 0. And then that's going to be equal to 10 when I subtract 46 from 56. And if 2w is equal to 10, I should have tried to eliminate w. I didn't really see that coming. I forgot that we were looking just for the length, but it'll be all right. Okay, so if 2w equals 10, then w is equal to 5. Okay. And then I will probably use the original perimeter formula. 2w plus 2l equals 46. 10 plus 2l equals 46. So, okay, if I subtract 10, 2l is going to equal 36, and then I divide by 2, and the length of the original rectangle is 18. All right, that was a good one. Now we've got just one more. The perimeter of an isosceles triangle is 42 millimeters. Okay, so I'm going to draw an isosceles triangle. That's one where two of the legs are the same, and then there's one that's different. Okay, so I'll call these x, and I'll call this one y. Okay, so perimeter is 42, so it's going to be 2 x's, x plus y. That's going to be 42. And if the base, I'm going to assume that's y, was lengthened by 7 millimeters, and each of the congruent legs were shortened by 5, okay, I think that's going to be, that wasn't a very good drawing, but okay, these were shortened by 5. This was lengthened by 7. Then the perimeter would be, wait, no. All three sides would be equal. Okay, well then if that's the case, then specifically this one equals that one, right? So y plus 7 is going to equal x minus 5. And from here, it doesn't really matter. Find the length of the congruent leg. So what I want is x. So I want to eliminate on y. And I think if I kind of work with this a little bit, and if I want to eliminate y, I want to get a negative y. So I'm going to try to get that y over here. So I'm going to subtract y from both sides. And then I kind of want this 5 to combine with the 7, so I'm going to add 5 to both sides. Okay, and then I've already got this 2x plus y equals 42. So since I'm going for one of the legs of the congruent legs of the original triangle, I want x, eliminating y. Okay, so, and I'm going to add these two equations together because that will eliminate y. Okay, so 12 plus 42 is going to be 54. That's going to be 3x. Okay. I'm going to divide both sides by 3. And I'm going to say, oh, all right, x is going to be 18. Because 54 divided by 3 is 18. And that's what they were looking for. One of the congruent leg lengths, well, that's going to be 18. Okay. And I think that'll be all for that one. All right, number 10, find the values of x and y that solve the system. All right. Okay, we're just going to do a little bit of, okay, on this one, we think, if you want to substitute on this one, sure. I think you would probably want to substitute on x, because that's one way you could solve for x and not have fractions. Because as much as possible, I try to avoid the fraction realm. But me personally, I'm going to try to eliminate. And I think I'm going to just eliminate on x. So I'm going to, because 2 and 3 don't have any common factors, I'm going to multiply this equation by 2 and this equation by negative 3. Okay, because that will give me 6x and negative 6x. So when I do that, I'm going to have 6x plus 12y equals 18. And when I multiply everything by negative 3, I'll have negative 6x minus 12y equals negative 18. Okay, and that looks a little suspicious, but I'm going to just go with it. I'm going to add them together. And then I'm going to see 0 plus 0x plus 0y equals 0. Oh, okay, that's true. And this one has infinitely many solutions. Evidently, these are just two names for the same line. Yeah, I see that. Okay. So for what values of k, if any, will this system have no solutions? Okay, this one's a little more challenging. I like this. So what we're going to want to do is we're going to want to eliminate on x so we can figure out what's happening with y. Okay, that's my plan here. So I'm going to need to multiply this one by 7 and this one by -2. Okay, so if I multiply this one up by 7, I'll say 14x minus 35y equals 1. No, equals 1 times 7. Okay, and then over here, when I multiply this one by -2, I'll have -14x minus 2ky equals 0 times -2. That's going to be 0. Okay, then when I go to eliminate, I'm going to add these together. So I'm going to have -35y minus 2ky equals 7. Okay, now if this is going to come back no solution, I need something like 0 equals 7. Okay, I can't have any number of y's equaling any 7, because then we could solve for y, and then we could solve for x, and then there would be a solution. Okay, what was I thinking? Oh, yeah. So if that's the case, the number of y's, which is going to be -35 minus 2k, right? That's, if I was to combine like terms, that's the number of y's that I would have. I need the number of y's that I have over on this side of the equation to be 0. So I'm going to say, all right, that's going to be 0. The numbers against the y's have to combine to 0 is what I'm saying. And then I'm going to solve for k by adding 2k to both sides. Okay, and then I'm going to divide both sides by 2, and I'll get k as -35 over 2. That one was a little tricky. And I feel like this is another one of those where there might be a better way of solving that problem, and if you've got a better way, like, I ask you to please let me know. Because I want y'all to be able to solve it the easiest way possible. That was just the first way that came to my mind. Okay, now, if this system has infinitely many solutions, what are the values of a and b? All right, I think on an infinitely many solutions case, know that you have 2 copies of the same line, right? So that means that really the second equation has to be the first equation multiplied by some number, right? If it's going to be the same line. So I'm going to say, all right, equation 2 needs to be equal to -2 times equation 1. Right, just in general, because of the 11y and -22y. If everything is -2 times as much, then I'd be able to eliminate and get 0 equals 0. Right, if I had everything the same, except, like I said, -2 times as much. So that means that, okay, this item in equation 2a, that's going to be -2 times the corresponding item in equation 1, which is 4. Okay. And then over here, again, b, the item in equation 2, needs to be -2 times the corresponding item in equation 1. And so that will be b equals -10. Okay, so if a is equal to -8 and b is equal to -10, then we would have infinitely many solutions. And I'm going to draw that in for you. So 4x plus 11y equals 5 versus -8x minus 22y equaling -10. Right, yeah, so if I doubled up the first equation and added it together, then I'd see that 0 equaled 0, and I knew I had infinitely many solutions. All right. Last problem is, I think, college student going to need 10 more classes that are worth a total of 46 credits in order to finish your degree. College offers classes that are worth 4 credits and classes that are worth 5 credits. We're going to write and solve a system of linear equations that gives me basically the exact number of each course that she needs to take to graduate, hopefully with a minimum amount of effort. So I'm going to say, all right, the total number of classes is 10, and we're going to say that the 4 credit classes are x. So x plus y, the total number of classes, that needs to equal 10. But then the credits needs to equal 46. The number of credits you get is 4 times the number of 4-credit classes and 5 times the number of 5-credit classes. Okay. And then I'm going to solve this system. Number 13. Okay, we can do this. I'm going to set up for elimination. I think on this one, I'm going to multiply the first equation by -4. So I'll have -4x, -4y equaling -40. And then +4x and +5y equaling 46. I'm not going to change the second equation, okay, because now I'm set up for elimination. So -4x plus 4x, that's 0. 5y minus 4y, that's just 1y. And if I take 46 and subtract 40, well, that's going to just be 6. Okay? And since x plus y equals 10, I don't even need to write that out. I know that x is going to equal 4. And so, okay, you know, if we, the best response is student needs 4 4-credit classes and 6 5-credit classes. Okay, let's check our answer real quick. Okay, that's 10 total classes. That'd be 16, and 30 is 46 credits. Okay, that makes sense. That's working. That's it. All right, that's all for this video. Hope it helped.